Elon Musk just revealed SpaceX's ambitious new plan to put humans on Mars. But there's a huge problem. Even with Starship exploding, delays, and impossible engineering challenges, he's doubling down. Here's why this might actually work, or fail spectacularly. Let's dive in. Starship production and mass scaling. Currently, SpaceX can produce one Starship every 2 to 3 weeks. However, version 2 of the Starship is yet to complete a successful test flight. Because launch windows to Mars only occur roughly every 26 months, pressure is mounting. In the future, SpaceX aims to produce 1,000 Starships per year. That's 3 per day. Each Starship is larger than a Boeing 747 or Airbus A380. This kind of mass production is unprecedented in the space industry and reflects Musk's experience scaling manufacturing at Tesla. Starlink Expansion. SpaceX also plans to build 5,000 Starlink version 3 satellites per year, potentially ramping up to 10,000 annually. Each Starlink V3 satellite is roughly the size of a Boeing 737. To support this massive output, the company intends to operate 2 Gigabay factories, one at Starbase, Texas, and another in Florida. Starlink is SpaceX's cash cow, and therefore critical to the company's long-term sustainability. The mission: a self-sustaining Mars colony. Musk's stated goal is clear: to enable anyone who wants to go to Mars to make the journey. The top priority is building a self-sustaining colony independent from Earth. According to Musk, this requires at least 1 million tons of cargo on Mars. Hopefully, not much more. Motivation and reusability. One of Musk's most striking quotes to employees: making science fiction no longer fiction. The team is currently developing rapidly reusable rockets. The goal is for a captured booster to be ready for flight within an hour. The next step is to catch and reuse the upper stage as well. Much hope rests on the Raptor V3 engine, a significant innovation. Besides eliminating the need for a heat shield on certain parts, it's more efficient and powerful. Musk referred to it as an alien technology rocket engine. This version will significantly improve payload capacity and reliability, addressing failures seen in test flight 7 and 8, particularly regarding engine restarts. Refueling in Earth orbit. One of the greatest challenges is in-orbit refueling. This has never been attempted before, and key questions remain. How high will fuel losses be during transfer? And how many tanker launches will be needed to fully refuel a Mars-bound Starship? Initial tests of in-orbit refueling, where 80% of the liquid oxygen is transferred, are scheduled for next year. Heat shield technology. Another critical hurdle is the reusable heat shield. Even Earth re-entry is difficult. After every space shuttle flight, heat shield tiles required months of inspection and repair. Mars complicates this further. Its CO2 atmosphere increases oxygen content during descent, which oxidizes the shield. Next-gen Starship and Specs. The current Starship is only an interim version. The next-gen Starship will be even taller and will feature open struts at the interstage, improving stage separation while engines are active. Planned specs. A 61-meter Starship with 9 engines, combined with an 81-meter booster, brings the system's total height to 142 meters. Payload to LEO, 200 tons, reusable, up to 400 tons, expendable. That's twice the capacity of the Saturn V, and unlike Saturn V, Starship is fully reusable. Mars timeline and the Arcadia region. Musk estimates a 50-50 chance of launching an uncrewed Mars mission by the end of next year, depending on the success of in-orbit refueling. If successful, a Mars arrival could occur by early 2027. The Arcadia region is SpaceX's preferred location for a Mars base due to its high water ice content and flat terrain. It's far enough from the poles and not too mountainous for landing. Interestingly, one of Musk's 14 children is named Arcadia, underscoring his long-standing fascination with the red planet. Tesla Optimus on Mars. The Tesla Optimus robot is expected to set up initial infrastructure before humans arrive. How well it will handle Mars's harsh radiation, frequent dust storms, and extreme cold remains to be seen. Crewed missions will only begin once the landing system and supporting infrastructure have been proven reliable. Looking ahead, one of the biggest long-term challenges will be building enough landing pads on Mars and figuring out how a human society will function there. According to Musk, the Martians will have to decide for themselves what kind of civilization they want. Would you volunteer for the first Mars mission? Comment Mars below, or Earth if you'd rather stay home.